Okay, everybody, we're going to do Chapter 3, Problem 20, Adirondack Savings Bank. To briefly go over what the problem is, Adirondack Savings Bank has $1 million in new funds that must be allocated to home loans, personal loans, and automobile loans. The annual rates of return for the three types of loans are 7% for home loans, 12% for personal loans, and 9% for automobile loans. The bank's planning committee has decided that at least 40% of new funds must be allocated to home loans. In addition, the planning committee has specified that the amount allocated to personal loans cannot exceed 60% of the amount allocated to automobile loans. All right, on Part B, it is asking us, well, I should say in Part A, it's asking us to formulate a linear programming model, which we do when we do this in Excel. Can be used to determine the amount of funds the bank should allocate to each type of loan in order to maximize the total amount of return for the new funds. So we're going to maximize total return. And so then the Part B tells you what, that'll be your red cell, and Part B tells you what the yellow cell should be, how much should be allocated to each type of loan. So your allocation will be your yellow cells. And then it says what is the total return, which will be the red cell, and what is the annual percentage return. Well, you can calculate that based on the red cell. So we're going to go and package all this together. Chapter 3, that's not a 3, Chapter 3, Problem 20. And we'll go ahead and set this up with the different kinds of loans. Home loans, personal loans, auto loans, and then total allocation. All right, expand this a little bit here. I'm going to put the amount we're going to allocate to each of those loans. So these will be our yellow cells. And we have to include the rate of the return in order to calculate the total return. It's a return rate. And over here we have to actually calculate the return for each type of loan. So we're going to multiply the allocation times the rate of return and get the return for each. And then we're going to sum all those returns down here, and that's going to get our total return right there. So that's going to be our red cell. This isn't a real tough setup. It's just we're going to add a little step onto the end that'll show you why we're covering this. Total return, and this will be the total percentage return. Okay, that's not a red cell because you can just calculate that based on numbers you already have. So let's go ahead and plug in the numbers we know. So this is 0.07 for 7% for home loans. For personal loans, it's 0.12. And for automobile loans, we're at 0.09. Okay, total allocation. And this is something we're going to need to calculate your total percentage return. So your total allocation is going to be what? That's given to us, and that's at $1 million. So we already know that going in. And then to calculate our return, we're simply going to multiply these two cells by each other. Once we do the first one, we're going to drag it down. And then here we're going to do an auto sum, and it just does it for me. It picked those three cells, hit return. And then total percentage return, what we're going to do is we're going to divide our total return by our initial allocation. Okay? And that'll be our total percentage return, which the problem asks for. It's not really necessary to do this. I mean, you can always calculate this from this number, but it asked us, so we're going to do it. Now let's set up our constraints. And the constraints were pretty obvious in this one, the second half of the problem, which tends to be the case. It says the bank's planning committee has decided at least 40% of the new funds must be allocated to home loans. In addition, the planning committee has specified that the amount allocated to personal loans cannot exceed 60% of the amount allocated to automobile loans. So, we also know that the total, that it says 1 million in new funds must be allocated to home loans. So, first we're going to do the total allocation, which is, we're just going to go, oops, equal sign to there. All right. We have to, and remember for the constraints, we have to tie in the yellow cells, and this is so we're going to tell the computer that these cells must total to 1 million, which means we set this up wrong. I apologize for that. This is an auto sum of these three cells. So it's going to be 0 now, but it needs to be 1 million. So I did that incorrectly. So these three cells must equal 1 million. So the total allocation, this will be this B6 number must be 1 million. Oops. I just want an equal sign in there. It doesn't like it when I do that, so we're just going to go. That's 1 million, and for me to put the equal sign here, doesn't always like that. Oh, let me do it. Okay. And then the next one is home loan allocation. Make this a little wider so it fits. Home loan allocation. So that would be B4, I'm sorry, B3, this is just equals B3, must be greater than or equal to 40% of the total allocation. Okay, so 40% of total allocation, so it's equals 0.4 times, which is 40% times the total allocation, which is B6. Remember, even though you know the total allocations in 1 million, in order for this sheet to work, you must use the reference, which is going to be total of the yellow cells. So you must use the reference there. And then we're going to have personal loans. And personal loans cannot exceed 60% of the amount allocated to auto loans. So personal loans, so we're just going to go equals B4, cannot exceed, so that means this will be less than, cannot exceed is less than, 60% of personal loans, which would be equals 0.6, I'm sorry, 0.6, 60% of auto loans, 0.6 times the auto loan number. All right, now let's hop into Solver. The objective cell is our yellow. We're going to maximize our total return. And the parameters means we're changing those yellow cells subject to what constraints. So we're going to add a constraint. That equals that one. Add that is greater than or equal to that. Add another. That. The cell is, that's already correct right there. And there you go. Hit OK. We want to make sure it's set up to be linear. And let's go ahead and solve. And our answer is 88,750 for a total return. Our allocations are over here, and this is correct. Now let's move on to part C. If the interest rate on home loans increased to 9%, would the amount allocated to each type of loan change? Okay, so if the amount on home loans increased to 9%, so that's this right here, we're going to go ahead and put 0.9. And let's kind of remember what these are here, because it's asking us if I change this to 9%, will the other allocations change? So then we just run Solver again after we do the change. Did they change? Nope. So that changed, but everything else stayed the same. So the answer to that, the allocation did not change, the total return did increase, which would make sense since you're increasing the return there. D, suppose the total amount of new funds available is increased by $10,000. What effect would that have on the total annual return? Well, let's change this back to 0.07. So the total funds available were to increase. We make that change right down here by $10,000. All right, did I do that correctly? Yes. All right, then we simply run solver again. How much did this change? Well, it was at 88,750. Now it's at 89,637, and we know it worked because the total allocation went up. So when we change that constraint, that total allocation went up there. And finally, assume that the bank has the original, this is part E, original $1 million in new funds available, and the planning committee has agreed to relax the requirement at least 40% of the new funds must be allocated to home loans by 1%. How much would the annual return change? How much would the annual percentage return change? Okay, so we're going to go ahead and switch this back to a 0. And it changed this requirement from 40% to 39%, the home loan allocation. It relaxed it by 1%. All right, so let's run solver again. And it asked how much would the annual return change. So it went from 88,750 to 89,662. So just that 1% difference made a change of over $1,000. Well, I'm sorry, about $300. And how much would the annual return change? How much would the annual percentage return change? Well, the original percentage return was 88,75, and now it's 89,063. All right, that's it for Chapter 3, Problem 20.